Okay, so in this video I'm going to have a look at some more hypothesis testing and looking at test statistics and p-values. So just to run through the background to this again, we're going to have a look at a normal curve again. This is actually a standard normal curve. So we've got a mean here of zero standard deviations from the mean. We've got 1, we've got 2, we've got 3 standard deviations from the mean. We have -1, -2, -3 standard deviations from the mean. Now we're going to look at the critical regions of the standard normal curve. So we're going to have a look at 1.96 standard deviations from 1.96 standard deviations from the mean. So that's roughly here. 1.96. So we're going to have a look at this region up along here, and we're going to have a look at minus 1.96 standard deviations. That's going to be here somewhere. So there's minus 1.96 standard deviations, minus 1.96. That's that value there. So these two blue regions here are called the critical regions of our standard normal curve. So within this region, we're going to fail to reject our null hypothesis. And if our z values appear here or here, we're going to reject the null hypothesis. So if z appears here or here, we're going to reject the null hypothesis. Now, so these two blue regions are called the critical regions, and they depend on the confidence interval that you require, really. And in our particular course, what we're going to do is look at a 95% confidence interval. We're going to look at a 95% confidence interval. Now, the critical region for a 95% confidence interval, the critical values for a two-tailed test. This is a two-tailed test because we're looking at the two tails of the curve, if you like, the left and the right tail. We're going to look at plus or minus 1.96 standard deviations. So if the modulus of z here, the modulus of z is greater than or equal to 1.96, we are going to reject the null hypothesis. Null hypothesis will be rejected. So this just means that if z then is greater than or equal to 1.96, or z is less than or equal to minus 1.96, then we reject the null hypothesis. That's just what we're saying here by the modulus of z. Okay, so that's our z value then. So we're also going to have a look at p-value in this particular case. So let's have a look. We're going to have a look at our p-value. Now p is just a probability, so it's a probability value that our test statistic or a more extreme value, so our test statistic or a more extreme value could occur assuming that the null hypothesis is in fact true or correct. So we're going to look at 5% level of significance, 5% level of significance. So, okay, 5% level of significance. And so basically, if the p-value, if our probability value is smaller than 5% or smaller than our significance level, then we're going to reject the null hypothesis. So in other words, again, if we appear up here or down here, this is going to be 5%. If you add the percentage of the area under the curve here and here, if you like, it's going to be 5%, 95% in here if you go by the empirical rule. 2 standard deviations, remember, by the empirical rule, plus or minus 2 standard deviations, within that is 95%. So then outside that is going to be 5%. Now we're talking about 1.96, which is close enough to 2 standard deviations. So 5% level of significance. If our p-value is smaller than 5%, then we're going to reject the null hypothesis. So, okay, I'm going to have a look at this problem here, and I'm going to work out a z value, see if it's greater than or less than 1.96 standard deviations from the mean, and then I'm also going to work out a p-value, see if it's less than or greater than 5%. So let's have a look at the problem itself here. So we have a bulb manufacturer. They make light bulbs with a lifespan of 200 hours. and a standard deviation of 15 hours. Now, after an improvement, they improved the manufacturing process, and they want to see, has it improved the lifespan of the bulbs. So they take a sample of 100 bulbs, and they find that the mean lifespan of the 100 bulbs is in fact 204 hours. So it looks like there is an improvement, but is that a genuine improvement, or is it just luck that they got 204 hours? So they're going to carry out an hypothesis test at a 5% level of significance to determine if there is evidence to suggest that the lifespan of the bulbs have improved as a result of the change in the manufacturing process. So let's first of all just write down our null hypothesis. Our null hypothesis in this case is that mu is still 200 hours. Okay, so nothing has changed. And our alternative hypothesis, H1, or some people write down HA for alternate, is that it's no longer 200 hours, that there is some kind of a change. Now, let's just write down the information that we're given in the question. We're given that mu is 200 hours. That's this value here. We're given that the standard deviation is 15 hours. Initially, that's this value here. We're told that we've taken a sample, or that they've taken a sample of 100 bulbs. And that when they did that, they got a mean lifespan of 204 hours. So this is all the information we're given in the question. So let's work out, first of all, a z value, see if it's greater than 1.96. Then we'll work out a p-value and see if it's greater than or less than 5%. So let's work out the z value first. So z, as we know, because it's a sample, is going to be our x bar minus mu over our standard error, which is sigma over root n. In this case, we have 204 hours minus 200. That's going to be divided by the standard deviation over the square root of 100. Now, when you work that out, you get 2.67. 2.67. So we can already see that our 204 hours is in fact 2.67 standard deviations from the mean. So we can see that we're already over our 1.96. So this is a significant value. This is an unusual value. So we're going to reject the null hypothesis, which states that our that there's no change in the mean lifespan of our bulbs. Okay, so that's our z value, our test statistic. So what we're going to do now is have a look at p-value. So let's have a look at our p-value then, our probability value. What's the probability of getting this particular result given that the null hypothesis is true? So we're accepting that the null hypothesis is true or correct. What's the probability of getting this particular result on this sample of 100 bulbs? So we want to work out a z value. So we want the probability that the modulus of z is going to be greater than or equal to 2.67. So in other words, what's the probability of being 2.67 standard deviations from the mean in both directions, right and left? So let's just work out the probability that z, first of all, is greater than or equal to 2.67. So we'll just do one side first, and then we can double it for the other side. So our curve will look like this, and we're looking at 0 here, 1 standard deviation, 2 standard deviations, 3 standard deviations, and we're looking at 2.67, so it's going to be up around here somewhere, and we're going to be looking at this area of the curve here. It's not a very good curve, but you get the idea. Now, when we look up 2.67, 2.67 is a positive number. We have a positive number table here. There are tables, I think, that give you negative numbers as well, but I just have a positive table here. So this table will give us the probability of being less than 2.67. So if we look up 2.6 and 2.6, there's 0.07 here. So we look up this number. We find this number here is in fact 0. Wait, I'll just test it out for a second. The probability of being less than 2.67 is going to be 0.9962, this value here. Now we want greater than, so it's in fact going to be 1 minus 0.9962. 1 minus 0.9962. So that's going to give me, let's see, 1 minus 0.9962 is simply 0.0038. Now we want, that's just on the right side, but remember we also need the left side as well. So we're going to go 1, 2, 3. So this is minus 3. This is going to be minus here. So we're also looking at this part here. So we want to double this. So 2 times 0.0038. That's going to give us, let's see, what's that? 0.0076. 0.0076. So that's going to be 0.76% in total. So we can see our p-value here. Our p-value is 0.76%. That is much lower than our 5% significance level. So the probability of getting this result is a lot less than our significance level. So we're in our critical region here. So we are going to again reject. We're going to reject the null hypothesis.